Why power factor matters. Good morning, everyone. The topic of our presentation today is why power factor matters. While it may seem like a purely technical metric, we will demonstrate that power factor is the defining factor for the capacity, longevity, and operational cost of any industrial or commercial electrical system. The core concept, the efficiency ratio. Let's start with a quick recap. Power factor is fundamentally an efficiency ratio. It measures the gap between the total electricity supplied to your site, the apparent power in kVA, and the actual useful energy that performs work, the real power in kW. As you see in the formula, our goal is always to get this ratio as close to unity, or 1.0, as possible. A low power factor means your system is wasting energy on reactive power that does no real work. Unlocking capacity. One of the biggest impacts of a low power factor is system capacity loss. Think of your electrical infrastructure, such as cables and transformers, as a fixed width pipe. The reactive power takes up space in that pipe. If 30% of your current flow is reactive, then 30% of your total infrastructure capacity is unavailable for productive loads. By improving the power factor, you instantly free up this valuable capacity, allowing you to add new production machinery without the enormous expense of upgrading your main transformers. Stabilizing voltage. A secondary, but critical, effect of low power factor is poor voltage regulation. The increased current required to compensate for the reactive component leads to higher voltage drops across your distribution cables. This results in voltage sag throughout your facility. This low voltage causes motors to lose starting torque and can cause sensitive electronic controls, common in modern manufacturing, to operate erratically or even reset and fail. Energy losses, physics. The financial implications of power factor are rooted in basic physics. Resistive power loss in any conductor is determined by the $I to R formula, where I is current. This loss is proportional to the square of the current. If your low power factor forces you to draw twice the necessary current, your heat losses don't just double, they quadruple. This effect, often called burning money, is a direct drain on efficiency, which you are paying for through increased energy consumption. Equipment failure. The heat generated by these $I to R losses leads to the premature death of your electrical assets. Excess thermal stress is the number one cause of equipment failure. Transformers and motors running at a sustained low power factor run constantly hotter than their design specifications, which quickly degrades insulation, stresses internal components, and leads to unscheduled, expensive downtime and replacement cycles. The financial penalty. In addition to internal losses, a low power factor results in direct financial punishment from the utility company. Utilities must size their grid infrastructure based on apparent power, or kVA. To recoup the cost of generating and transmitting non-working reactive current, they impose significant surcharges on customers who operate below a specified power factor threshold, often 0.90 or 0.95. As our simple chart illustrates, a poor power factor can easily add 25% or more to your monthly bill. Correction equipment offers an extremely fast return on investment, often less than 2 years, simply through penalty avoidance. Summary of benefits. To summarize why optimizing your power factor is essential, we achieve 3 primary benefits. First, you cut costs by eliminating utility penalties and reducing your overall kVA demand charges. Second, you gain capacity, effectively upgrading your existing infrastructure without capital investment. And third, you extend life by running all your crucial equipment cooler and more efficiently, reducing failure rates and costly downtime. Conclusion: power factor correction is not just a regulatory compliance box to check, nor is it merely an expense. It is a high return, strategic investment in the long-term efficiency, reliability, and profitability of your entire operation. It is time to optimize your power. Q&A. Thank you for your time. I am now happy to answer any questions you may have regarding power factor analysis, the selection of correction equipment, or calculating your facility's potential savings.